Hi everyone. Good afternoon, guys. Good afternoon, everyone. How are you all? Everyone, how are you? So, all of you had your lunch? Everyone had your lunch or not? All of you. Audio and video both are clear, everyone? Somebody? Somebody just respond. Audio and video clear or not? Right. So, we'll be continuing our discussions on this, you can say. Which discussions we are doing? Right. Billy. Yes, very good. So which discussions we were doing in the previous class? That rigid flexible payment discussions we were doing, na? So no, flexible payment discussions we were doing in the previous class, right? Right. So this is highway quick revision series we'll be seeing now. No, all of you, welcome to Unacademy. Let's crack it, right? Everyone get ready to crack. Everyone get ready to crack or not? Be ready to crack, all of you, everyone. What is that referral code you have to use, right? Whenever RP Civil is the referral code you have to use, you can say, if you just read RP Civil is the referral code you have to use when you are subscribing to the Plus and Iconic courses, right? Yes, no? So this is my profile, you can say, and this is the referral code you have to use always, right? You recommend this code to your friends, juniors and everybody, right? Now here these are the Unacademy Gate 2024 toppers, you can say. Right. So this is which one? These are the Gate 2024 rankers from which one? This Unacademy, you can say. Now here everyone, right? Everyone. So you go through this, right? We are having this Unacademy Learning Festival, right? Unacademy Learning Festival is going on, right? What is that Unacademy Learning Festival? You can say you can get this unlimited access, right? What is the meaning of unlimited access? Is there any restriction for the classes or no restriction for these classes? No restriction. Unlimited access, you can get it for which one? Gate plus subscription for which one? Next 7 days, right? So you just scan this QR code, or that is also there. That is also there. The link is also pinned, you can say. The link is also pinned. Yes, no? The link is also pinned, you can say. Okay, the link is also pinned just below this video. Yeah, Shruti, good evening, good afternoon. Okay, so you can access which one? This all online live on these recorded batches study material you can access by these top educators, right? So you can go for which one? This 2 lakh plus practice questions you can access, and mock test and PVQs also we can access. 24/7 this doubt clearing session you are having, right? Right, you can just scan this, right? You can just scan this QR code, right? You can just scan this QR code, you can say, and you can get access to these, right? So these are the steps, right? Enter your phone number, and what is it, you can say, verify your phone number with OTP and choose your target exam, and you can enter your activation code, right? What is that activation code you have to enter, right? RP Civil is the activation code you have to enter, and after that you can start downloading the app, and which one? You can start downloading the app, and which one? You start accessing all these classes, everyone, all of you, right? So these are the free Unacademy plus subscription for free for 7 days, you can get it, right? These are the features of this place, right? And now if you just observe, these are which one? This latest batches started, right? What are these latest batches started? Latest batches started, right? So which subject? These are the subjects you can say, right? On April 30th, they have started, you can say, right? On April 30th, they have started these latest batches, right? Don't miss these batches, right? Those who are going for this 7-day free trial also, those who are going for this 7-day free trial also, they can access these batches, na? They can access these batches, na? Isn't it? They can access these batches also, right? These subjects also, very important subjects, high weightage subjects you can complete, you can say, right? If you are doing which one, this daily 3-4 classes or 4-5 classes if you are doing, right? Like that. So don't miss this opportunity, everyone. So these are the Aarambh batch for 2026, Sankalp batch for this ES environmental science paper, it is there. Now, so this is Aarambh batch for this ES 2026 is also there. So those who are taking iconic subscription, these are all the books you will be getting printed, right? These are all the printed books you will be getting, right? These are all the printed books you will be getting, you can say, right? Delivered to your house within 15 days, right? Now coming to this, right, which part we are discussing, you can say, if you just observe uh, that last one, rigid payment we were flexible payment we were discussing now, isn't it? Which part we were discussing, if you just remember, that flexible payment we have discussed, right? That last class, if you just observe it, a previous class now, flexible payment discussions were running, right? So what is it, you can say, this one, vehicle damage factor done, is not? Vehicle damage factor done, anticipated traffic it is done, and design traffic it is done, right? Design traffic, and what is that, you can say, whenever you are going for this, right, how much amount of traffic we have to study for this vehicle damage factor estimation, and what is that, you can say, to take care of this uncertainty, that load safety factor we are having, and what else we will be having, you can say, this is your lane distribution factor, right? Lane distribution factor we had, and CSA, cumulative standard axle repetitions we had, right? Up to this point we have completed, if you just observe, right? So anyone having any doubts in our discussions up to the class? So this is your which one, this lecture 20 will be continuing that. Today flexible payment will be over, mostly we may start which one, this rigid payment also, if you just observe, right? Got it? Right. So those who are willing to access this 7 days free trial for this place, just scan this QR code, everyone. Scan this QR code and use the referral code RP Civil. Right? RP Civil is the code you have to use, right? So those who are scanned, tell me. We'll try to move on to the next then. So this is which point got completed? 241 point completed now. Now this is your 242 point, you can say. This is your 242 point, you can say. So what is this point? Next point required, if you just observe, whenever, if you consider, did we discuss about this fatigue and all these things, right? Fatigue and this rutting criteria was not discussed now. So whenever this fatigue and this rutting criteria is not discussed, right, we have to discuss about that only, definitely or not, because only which one is important, tell me? Only that vehicle load is important, a number of standard axles, how much they will commit is important, or whether it is subjected to failure or not, that also, that checking is also very important, tell me. That checking is also important enough. So can we just skip that part? We cannot skip that part, you consider that type of checking is also very, very important, if you just observe, right? So after this cumulative standard axle repetitions, what is it we are having, right? This is a resilient modulus of soil. So resilient, what is it, a resilient modulus of soil, everyone? Resilient modulus of soil, right? Resilient modulus of this soil, right? What is the resilient modulus of soil? What is the resilient modulus, tell me? Anyone having idea? Anyone having idea about this resilient modulus, all of you? This resilient modulus of this soil MR will be equal to 10 times what? CBR. When we have to apply this, if that CBR value will be what? If that CBR value will be lesser than or equal to that 5%, right? If the CBR is lesser than or equal to 5%, right, you take it like this, right? But stored energy, so strength of material, okay, that is strength of material, right? Here, what is that another formula we have to use, right? That MR modulus, resilient modulus will be equal to which one? This is 17.6 into, what is that you can say? CBR power this 0.64, right? When we have to go for, if the CBR is what? Greater than 5%, now. If the CBR is greater than 5%, we have to go for, right? Like that, isn't it? Now, that is a modulus of resilience you have to calculate. Now, coming to this, design of this flexible pavement we have to see now. Design of this flexible pavement we have to see. So what is that you can say? CBR method, right? What is the CBR method? There are some design charts you are having. CBR method or this design charts method, right? What is the design charts method, right? Anyone having idea? Right, design charts, right? Do you have any idea about this design charts, all of you? What are these design charts, right? So these are given in 1960s, right? Using these design charts, we'll be getting this thickness, na? So we'll be getting this thickness, you can say, just right here. What is that we are having? This is the graph you are having, you can say. On this x-axis, right, what is the value we have to take? That is your CBR percentage value we have to take, but it will be on this log scale, na? Just a direct CBR value we have to take it, or we have to take the log scale value? We have to take this log scale value, na? And on this y-axis, right, what is that you can say? That is your thickness h. It will be increasing in this manner. So this is increasing in this manner, right? Now tell me, how the curves will come into picture? Tell me, these design charts we have mentioned, na? Design charts, na? So we will be drawing which one this we will be getting, we will be using these design charts, na? And these are directly or inversely proportional, tell me. Suppose if the thickness of this pavement is higher, or CBR of the soil is higher, when the CBR of this soil is higher, do you have any problem? It will take higher loads only also, no? When it is taking the higher loads, whenever it is taking the higher loads, it is better you have to go for which one, tell me? Whenever it is taking higher loads, so you can transfer higher loads onto this or not? Yes, you can transfer higher loads onto this, definitely, right? So lesser thickness of pavement is also okay, na? Because finally who is supposed to take all the loads? That of subgrade soil is supposed to take all the loads, right? CBR of which one, tell me? CBR of this subgrade soil, na? CBR of which one? This is subgrade soil, you can say, right? CBR of this is subgrade soil, if you just observe, right? Isn't it? Now, if subgrade is stronger, what happens? Lesser thickness of this pavement is also okay, na? Because whenever you are having this lesser thickness, see here, what happens if you just observe? This is your pavement, right? These are the different layers of this pavement, you can say. Okay, Shruti. And what is this bottommost one, you can say? That is your subgrade soil, na? Subgrade soil, right? Let us say your vehicles are running like this. If you just observe, this is your thickness, right? Now tell me, same one, same number of layers only, right? But what is that I am doing is I am providing this lesser thickness. Yeah, lesser thickness if I am providing, right? So here, what is that you can say if you just observe? This is your CBR of this subgrade is equal to here, let us say 10%. And here what is it, you can say CBR of this is upgrade will be equal to some 6%, you can say. So when higher CBR is there, higher CBR is there means we can transfer higher loads onto this now. Do you have any problem in transferring the higher loads? Let us say if it is 100 kilonewton, if you just observe, by the time it comes here 90 kilonewton, right, 80 kilonewton, and this is 70 kilonewton, right, higher loads also it can bear because CBR is higher. Now here let us say if you are transferring the same load, right, 100, what it will become, 190 up to this point it will become 80 na? No, I am explaining that only. This is 70, this is 70. Right, so here now here if you just observe, right, this is 70, by the time this comes here 70 kilonewton it will come. Now by the time it comes here, right, it will become this 50 kilonewton na? By the time it will come here, that will become this 50 kilonewton na? Yes or no? By the time it will come to the bottom, it will become this 50 kilonewton, right? Why we are getting this lesser load, tell me. Here more thickness is there means intensity of load is decreasing na? More thickness is there means more decrease in the intensity of this load na? The higher load at the top will become which one? This where is it pen working? Yeah, the higher load at the top will become which one? This very smaller load at the bottom when thickness is higher. So if you want a smaller load at the bottom, then you can provide which one? Higher thickness. But if you want higher load is also okay for you know, then you go for this lesser thickness. Now tell me Shruti, if CBR of this soil is higher means it can bear higher loads. When higher loads it can bear, we can get the higher loads also no? We can make higher loads also no? Is it no? For higher loads we can allow higher loads also, no problem, because if the CBR of this soil is higher, it can bear more loads, and if you are allowing higher loads there is no problem. How can you allow higher loads, tell me? By providing the lesser thickness of this pavement or higher thickness of this pavement? Lesser thickness of this pavement, right? If the CBR of soil is lesser, strength of this soil is lesser na? When strength of this soil is lesser, it cannot bear higher loads, it can bear only lesser loads. Then we have to transfer the top loads to the bottom, and intensity should be decreased by larger, and by the time it is transferred to the soil we should get very small load value na? How it is possible? When you are taking more thickness, then only it is possible to have which one? This very small loads by the time it is transferred to this subgrade soil. Got it now? Understood, Shruti? Clear now? Yeah, how to make a daily plans? How to make daily plan? Not able to follow the timetable. Yeah, see, whenever you are making, if it is daily, what you do is 3 subjects you try to finish it off. Okay, if you are going to college na. CBR, yeah, thickness is more with CBR is less. Yes, that is what I am telling na. Yes, when CBR is lesser, thickness is more. Is that only I have explained till now? CBR, yeah. When thickness is when CBR is higher, na, thickness will be lesser, right? CBR is higher, thickness lesser, CBR lesser, thickness higher, right? Like that. Yeah. Mohit, you have to follow this definitely, right? You have to follow. Yeah, soil strength is lesser, it can take a lesser load only. So to transfer the lesser loads, we have to decrease the intensity by larger extent. So we have to get the small value at the bottom. How can you get the small value at the bottom? Only by means of which one? This is a larger thickness. If you are providing small value at the bottom, you can get it. Yes, now got it now? Understood? Clear? Right. Yeah. Mohit, are you college going student or working, or you are just focusing on preparation only? Only you are doing preparation. What category you belongs to? You keep the targets daily, right? Daily targets, right? Before sleeping na, you just assess yourself, right? How much it is done, how much you have completed, right? Is na daily plan how to make means, right? What you do is daily plan how to make how to make this daily plan means, right, first you select the subjects first, right, you whether you wanted to go in the recorded or live, right. So here morning one subject 2 hours, right, next 2 hours afternoon another subject, right, evening 2 hours another subject, right, you make it, right, 3 subjects, right. So 2 technical subjects and 1 non-technical subjects you go for, right. One higher weightage technical subject, one normal weightage medium weightage technical subjects, right, or one bigger subject and one smaller subject, like that you have to select. And suppose if bigger subject is planned for this some 2 months, let us say 2 months you are planning the bigger subjects now, daily you have to allocate that time slot of, let us say, afternoon. If you just observe, you are allocating that for this now, then during this bigger subject is completed, smaller subjects you have to do 2 or 3 smaller subjects you have to complete it. By the time, let us say, mathematics is completed, right, you have to complete which one, this is some 2 to 3 smaller subjects, you can say, like that. So morning one slot, 1 2 hour slot, afternoon some 2 hour slot, right, evening 2 hour slot, right, like that you keep it. 6 hours, right, 6 hours for which one, this only study you keep it. And remaining hours in between, what you do, one slot for this revision, is not one slot for which one, this PYQ solving you keep it, right, one more slot, right. So 1 hour for this PYQ solving and 1 hour for which one, this revision, you can say, right. So that 8 hours gets completed now. Still if you are having time now, PYQs only you keep it for this 2 hours or 3 hours for 3 different subjects, right, like that if you do now, then daily early morning immediately after waking up, right, okay, open your timetable and okay, this is the target. Before sleeping, what was the target and what is it completed, right, and try not to sleep until the target is completed, okay. So that what will happen now, next time just for sleep sake itself you yourself will be completing that target, okay, so that you can sleep early. Your mind will be saying that, your body will be saying that, Arayar, you have to complete this during the daytime only, so that you can sleep properly, right, like that it will say. So daily morning and evening, immediately after wake up, what is the target, and night before sleeping, what is the achievement you have done, right. So like that you have to do it, right, daily. If you are doing, you can go through this, you can crack any examination easily, right. Now, so here this thickness and this is CBR are inversely proportional or directly proportional, you can say. This thickness and this is CBR are inversely proportional to each other, na? This thickness and this is CBR are inversely proportional to each other, na? Inversely proportional. So therefore the curves will be directly proportional curve will come or inversely proportional curve will come. Inversely proportional curve only will come into picture, na? How this curve comes into picture, you can say, if you just observe. This is how some curves will be there. So like that we'll be having these curves, A curve, B curve, C curve, D curve, like that we'll be having, okay. Now here what you need to do, this is CBR value, it is there. So first you select the curve A, B, C, D based on which one. Let us say this curve A is corresponding to which one, this is 0 to 15 commercial vehicles per day, right. Curve B is corresponding to which one, that 16 to this 45 commercial vehicles per day, right, like that. So C curve will be for something, right, like that. How many curves will be there, F6 curves will be there, right. So first which one we have to select, you can say, first we have to select the curve, na? Based on the traffic, anticipated traffic, we have to select the curve, right. Once the curve is selected, what happens, tell me. Once the curve is selected, you just estimate the logarithmic value of which one, this is CBR, log of this CBR you estimate, and what, suppose if it comes here. Now this curve C is selected, let us say. Now what you do, from this CBR value, you just draw a vertical line up to the curve selected. We have selected curve C corresponding to the traffic now. Then after that, where it is intersecting the curve now, there you draw a horizontal, that will give which one, this thickness, right, that will give which one, this thickness, let us say, right, some 150 millimeter thickness, just for an example, okay, like that. So is it clear how to get this thickness based on the CBR value? How to get the thickness based on the CBR value, right? Is it clear, everyone? Is not clear or not, Sudhi? Right, note this and tell me. I'll move on to the next. Hello. Right, done? What is COVID? COVID 0 to 15? 0 to 15. Curve A, there are different curves A, B, C, D you are having now. CVPD, commercial vehicles per day, 0 to 15. If you are what is that you can say? If your traffic is 0 to 50, in between this 0 to 15 commercial vehicles per day, na, curve A we have to use. If it is from this 16 to 45 commercial vehicles per day, na, you have to use this curve B. Like that, for different traffics we have to use which one? This different curves, right? For different traffics we have to use which one? These different curves we have to use. Absolutely. Is it clear now? Different curves we have to use for which one? These different traffics. Once the curve is selected, get the CBR value. From the CBR of CBR log value, so you draw a vertical line and it will be intersecting the curve selected at a point, and from that intersection point draw a horizontal. That horizontal will be intersecting with y axis. It will give the thickness. Understood now? Clear? Clear now, everyone? Right? So shall I move? Right. So here, now here if we just observe theoretical formulae, okay, CBR method only, this first one, based on this, which one? This design charts. Second one is what? The design based on which one? This formula, na? Based on this design formula you have to go for it. What is it based on this design formula? If you just observe, H is the symbol we are giving for the thickness, na? H is equal to under root. Okay, I'll write only one formula. We just modify that formula into the required format. H equal to what is it? You can say 1.75 times this capital P divided by this CBR minus which one? This A by pi. Okay, A by pi whole power which one? This 1 by 2, or you can also write it as which one? This is root P if you take it outside. What is it? You can say 1.75 divided by this CBR value, that you have to substitute in the percentage only, minus what is it? You can say 1 by this small p into that pi, na? Right? Got it? So what is that small p? You can say here that small p is your tire pressure, na? Small p is your tire pressure in which one? This kg per this centimeter square, right? That is your tire pressure in kg per this centimeter square, right? What is the capital P? You can say that capital P is nothing but your wheel load. Wheel load in which units? Kg. That is CBR percentage value, na? CBR percentage value we have to substitute, right? Now what is the capital A? You can say area of contact, na? How can you get this area of this contact if you just observe pi into that small a square? Listen, pi into that small a square, or not? Pi into that small a square, you can say. Got it? So what is that? This is the one we are considering, na? Contact area of this wheel load. Like that. Okay? That is a one, right? So this is thickness in which one? This H is nothing but your thickness of this pavement in centimeters, na? H is nothing but your which one? This is thickness in centimeters, na? Thickness in centimeters, you can say. Got it? Area of this contact in which units? Centimeters square. Like that. Is it clear? Do you remember this formula, everyone, or not? Do you remember this formula or not, all of you? Yes, no? Right. So now we'll be going for which one? This IRC method. What is that IRC method? You can say because of the limitations of the CBR method, we have modified this CBR method, IRC method, or this modified CBR method, you can say, right? What is the IRC method or this modified CBR method? If you just observe here, let us say these are the different layers will be having, or not everyone. In the pavement only one layer will be present or many layers. H is the thickness of pavement, na? H is the thickness in centimeters, na? H is which one? Pavement thickness in centimeters, okay. H is your which one? This pavement thickness. Here we are talking about this pavement design, means which thickness we'll calculate, tell me. Already we have mentioned na thickness of this pavement somewhere previously also. Right, okay. Here what is that we are having is, right, these are the different thicknesses you will be having, just for an example. Different layers will be having, don't worry what are the layers we are going for. H1, H2, H3, H4, like that you are having, let us say, right, 4 layers are there above the subgrade, just for an example. It may be 6 layers, it may be 7 layers also you may be having, is not? Now what is that we are having is, these curves are for which one? This is CBR of some X percentage. These bar charts will be there. So on this y-axis, right, what is that you are having? That is your thickness in millimeter. Na? On x-axis, what is that you can say? Cumulative standard axles in which one? Million standard axles, na? In terms of this million standard axles in the design lab. Okay, so like that we'll be having which one? These bars. So let us say that suppose that cumulative standard axle reputations will be equal to which one? This is millions, some y million standard axles, right? So what is this? We have to go for it. This is your 0, 10, 20. This is your 30. This is your 40. Let us say, so that y equal to 30, for example, right? Then which bar we have to select? Right? This bar we have to select. Na? So corresponding to the CBR, each and every bar chart will be there. For every CBR value, there will be one bar chart you are having, right? For different CBR values, different bar charts you are having, you can say, is na? For different CBRs, different bar charts you are having. First we have to choose which one? One bar chart corresponding to the CBR value. One bar chart corresponding to CBR, we have to choose it. After that, right, what is it we need to do? In that bar chart, you have to choose the bar corresponding to this cumulative standard axle reputations represented in terms of million standard axles, na? Is that no? In terms of this MSA, we have to choose which one? This one bar. After that, right, what is it you can say? How can you get the thickness? Tell me. How can you get the thickness? Tell me if you just observe. They are given differently like this, isn't it? So this top thickness will be your which one? H1. This second one is representing, first one is representing the first thickness, second one is representing the second thickness, third one is representing the third thickness, and fourth one is representing which one? This is fourth thickness. Now, like that, we are providing it, right? Is it clear now? Is it clear now how to get the thickness based on this modified CBR method or this IRC method? It is easy or it is difficult to tell me using this modified CBR method, all of you? It is easy or it is difficult, right? It is easy only, no? So no, it is easy only, you can say, right? Yes, na? Note this and tell me. Cumulative standardized repetitions. I have already given in the previous class, na? You forgot everything. This one, 365 into that A into 1 plus R power N minus 1 by this R. Do you remember? Recollect or not? Yes, na? This formula, do you remember or not? Then this is how we'll be getting which one? This cumulative standardized repetitions, right? Yes, na? No. Now here, what is that we have to consider again? If you just observe, KPSR class is there now at 2 p.m. Do you have KPSR class or not? If KPSR class is there, I'll close. Otherwise, I'll continue. No? Right. Fatigue cracking. What is that fatigue cracking? You can say here if you just observe 10% area is having which one? 10% area of total road have which one? 20% cracking, na? Then it is called as your which one? This is a 90% reliability. Suppose if 20% of this area, 20% area of this total road, if it is having this 20% cracks, same, then it is called as your which one? This 80% reliability. So this is the reliability criteria, right? When 20% of the surface is subjected to cracking, na, then it is called as which one? Suppose if you just observe, right, what is it you can say? Let us say this is your road considered. So let us say that road will be 1000 meter cube, just for an example. If it is a 1000 meter cube, na, right, what happens? You can say you have to consider which one? Failure must be everywhere or failure is at only some place. This is 20% of which one? This area. 20% is equal to which one? This 20% of this 100,000 is what? Sorry, 10% area. Na? 10% of this total area has 20% cracks. 10% of this total area means what is it you can say? What is the area of this road? Area of this portion? 100 meters square. Out of this 100 meters square, the cracks should be present for which one? 20% of this 100, na? 20 meters square, right? What is now? That is your fatigue cracking. That is your which one? This fatigue cracking, right? Yes, na? Now, what is that fatigue life? Fatigue life, right? What is the fatigue life? Tell me. Anyone having idea? What is the fatigue life? What is the fatigue life? Anyone having idea? Any idea? So here Fatigue cracking means that 90% reliability I have explained. Let us say total, what is that you can say, 1000 meter cube area is there, meter square. Total 1000 meter square area is there, right? Meters, it is not meter cube, it is meter square. Yeah, that is writing mistake. Thousand meter square area is there, right? Out of this 1000, how much area is affected? 10% area is affected, na? Then you can say 90% reliability, because 90% area is not explained. If only 20% of the area is affected, na? 20% of the area is affected, other 80% of the area is not affected, so 80% reliability, right? Like that. Understood now? That one, 10% of this total length only getting affected, right? 10% of this 1000 is how much? What is the 10% of this 1000, all of you? 10% of this 1000 is your 100, na? That is your 100 meters square. In this affected area also, only how much cracking? 100% of this area must be having cracking, or only 10% of the area is 20% of the area is having cracking. 20% of the area is having cracking. Right? 100 meter square is a 10%. Out of this 20% we have to take, right? So 20 out of 100 is what? Is it not this 20 meter square? Clear now? What is the fatigue cracking? Is it clear? No. Fatigue life, right? What is the fatigue life? You can say, if you just observe. Number of equivalent standard axles, right? So there can say number of equivalent standard axles required for which purpose? Right? Number of equivalent standard axles required to cause above fatigue failures, right? Above fatigue failures means one is 90% reliability related failure, other one is 80% reliability failure, you can say. So now tell me, this fatigue life is based on which parameters? If you just observe. Pawan, good afternoon. This fatigue life depends on which one? Fatigue life depends on which parameters? Tell me, everyone. First and foremost parameter. Parameter, what is it you can say? Maximum horizontal tensile strain. Maximum horizontal, which one this? Tensile strain, where? At which location, tell me? at the bottom of bituminous concrete. Where it is? At the bottom of this bituminous concrete only, no? Now, what is the second parameter it is influencing? Second one is what? Elastic modulus of elastic modulus of which one you can say? Bituminous concrete layer, na? Bitumen concrete. What is the meaning of this bituminous concrete? Tell me. What is it? The top layer is only bituminous mix, na? Everyone. Top layer or bottom layer? Like that. Okay. These are the parameters influencing which one? This fatigue, right? Fatigue life. The fatigue life formula is there, but I am not going to write this fatigue life formula. N equal to some formula is there. Don't worry about this formula. Is it clear now? So in the next classes, we'll be continuing with the rutting and after that rigid pavement and everything comes into picture. Right? Clear now? Shall I close? Any doubts, anyone? Anyone having any doubts? Noted? So here if we just observe why we are selecting it only at this place is because this top layer, right, this maximum horizontal tensile strain means this is your epsilon T at which one? This bottom of this bituminous concrete, right? It is not bituminous, it is bituminous concrete. It's not bituminous concrete bottom. Okay. Now this is, and also what is it you are doing, right? Modulus of resilience, MR of this bituminous concrete we are doing now, because the cracks will occur in the bottom layers of the pavement or the cracks will occur in the top layer of the pavement only. Cracks will occur in the top layer of the pavement only, no? So that's why the top layer properties we are selecting. Clear? Thank you all of you. Have a good day. We'll proceed again. Day after tomorrow, tomorrow we'll be having that song, and day after tomorrow again highway live test will be there, right? Thank you.